Heating effect of current is basically, see, if you have, we have already read what is power dissipated, right? And power ka formula tha, power was basically work done per unit time, okay? And and um, and we found out that in electrical circuit, the power formula was P is equal to V into I. This is the formula, right? And we also did, because Ohm's law says V is equal to IR. You put that V here, you'll get power is equal to I square R. Or if you put this I here, you get power is equal to V square by R. Fine. Right. Isko write it again, okay? Done. Next thing is, suppose if you have a resistor, okay, and you have a battery connected, the potential of the battery is V, the resistance of the battery resistance is R, the current flowing in the circuit is V by R. So if I ask you what is the power, sorry, power dissipated through resistor is equal to, either you can say directly I square R, because I is the current passing through the resistor, right? I is the current passing through the resistor, and R is the resistance of the resistor. The power dissipated through resistor, okay? Now, what is the meaning of the statement? Power dissipated. Power dissipated through resistor. It means the resistor, through the resistor, this much amount of power is radiated, or dissipated means it disturbed, disperses. Okay, it gives out to the environment. Okay, it gives out. So let's say the bulb is, so the language is the bulb is dissipating light. Okay, so the same, in the same way, the power resistor is dissipating the power. Okay, fine. Does anyone have any question till here?
So yeah,
Hmm.
like when you say that the bulb it is dissipating power you're
Hmm.
providing, like it has, right? So that means power and brightness are not like directly proportional, they're one and the same,
You
right? Because
think, oh, you are saying the power and brightness are one and the same.
yeah, the magnitude of power is the same as the magnitude of brightness it's giving out, right? Because that power is being given out in the form of light energy.
Okay, so right, this different devices, different devices convert this power into different forms. Okay, different devices, different electrical devices. Actually, right, electrical devices. Okay, different electrical devices convert this power into different forms. Okay, understood. Now, let's come to the next page. Okay, let's say there is a bulb. Bulb will convert this into heat plus light. Heat थोड़ा सा कम है, it is less, and light it is more. Okay, understood?
Yes, so.
Most of it is converted to light in the case of bulb. Let's say there is a fan. Fan will convert into motion plus heat. So motion is more and heat is less. Okay, let's say you have a
Why is it giving out heat?
fan gets heated,
Oh yeah.
right?
Yeah.
Because there is current passing through some resistor.
Also, I have written less heat. Like, with time, it will get heated more, no?
With time it will get heated more, but the portion of this is not with time. This is, I'm saying, the portion of, देखो इन दो सब में power आ रहा है, power मिल रहा है सबको ना,
Yeah.
तो power input same है, but the bulb is converting most of that power into light and very less of that in heat.
Okay.
And fan का क्या कर रहा है, वो heat में motion में ज्यादा है,
Oh, okay. Fair.
और इसको ऐसे भी बोल सकते हैं काइनेटिक एनर्जी, मोशन की जगह काइनेटिक. ओके, हीटर क्या करता है, हीटर हीट में जाता है मोस्ट
Hmm.
और थोड़ा सा लाइट में लेस.
So, इसमें light energy is just for like lighting of the bulbs, right? जो होते हैं.
इसमें
Light energy is just for showing the indicators which are on the.
नहीं 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 नहीं, कोई भी तुम अगर हीटिंग कॉइल देखोगे वो थोड़ी सी जलती है. तुमने ओपन हीटर्स पुराने वाले नहीं देखे ना, जो घर में ऐसे,
देखे मैंने सर, वो
तो
देखे.
वो जलता है ना ऑरेंज कलर से.
हाँ, वो जलता है थोड़ी देर बाद हीट होने के बाद.
हाँ वही, वो उस लाइट की बात कर रहा हूँ, इंडिकेटर लाइट की बात नहीं कर रहा हूँ.
Okay.
ओके, एनीवे विंटर्स में which heaters you use, no, these days
Yeah.
Crompton के अच्छे अच्छे से आते हैं, you know, they have
Hmm.
heaters, they also glow up, right? That glow is not, you know, designed to be glow up, so glow की जरूरत नहीं है, but because the heating is so much cheaper, okay, it glows. Fine. और कोई इंस्ट्रूमेंट बोलो. Which has different kind of energy outputs.
So, power adapter.
Pardon?
Power adapter.
The power adapter is not an instrument, it is a way of converting one to another.
Oh.
So like a cloth iron.
With the same comes under heater.
Okay.
Anything which heats up comes under heater. Okay.
Right.
Yeah. There is one thing which is alag, वो है microwave.
So fridge.
Microwave क्या करता है? It is, most of it is in, उसको बोलते हैं electromagnetic wave, EMW, which is also called microwaves. इस case में especially microwaves, and very few of them is light. Okay. EMW. So it generates microwaves. Okay. So microwave, it does not generate heat. Okay. Microwave does not generate heat. It works on the principle, it generates microwaves. Those microwaves travel, and the frequency of microwave is such that it only oscillates the molecule of water. Wherever it encounters water molecules, it oscillates them. So when they oscillate, they gain higher energy, and therefore the temperature increases. Okay.
So in microwave, heating effect is not like normal heating effect.
No, it is not like normal heating. Good. It is not like normal heating.
So like suppose you keep dry food in a microwave.
Will not get
Heat.
heated up that much.
Right. Okay. But it will get heated up, right?
Because of the moisture content. Because everything you have
Yeah, everything has a little bit
has
moisture.
some moisture content, has some water. But if you keep a dry thing, such dry that it has negligible water content, it will not get heated up.
Okay. Right.
That's why one thing is very, you should always be careful while eating those things which have a liquid filling inside a solid object. For example, let's say like a Ferrero Rocher kind of thing. Ferrero Rocher has a solid outer cover, but a liquid inside, right?
So I haven't eaten one, so I won't know.
Ferrero Rocher you haven't eaten.
I've eaten everything else.
नहीं.
So inside filling of chocolate, like fluid.
अंदर लिक्विड है और बाहर सॉलिड है ना.
Yeah.
तो इस तरह के मटेरियल देखो we don't actually heat Ferrero Rocher and eat, we just eat it directly.
Yeah, it's frozen mostly.
But those things, like there are some cookies, there are some biscuits, baking biscuits which are liquid inside.
So like dark fantasy.
Yeah, dark fantasy. Never ever heat dark fantasy in a microwave and eat it, because बाहर पानी नहीं है ना, बाहर वाटर नहीं है, तो बाहर वाला गर्म नहीं होगा, लेकिन अंदर वाटर है उसमें, अंदर
So
तो
it will get heated up a lot.
तो जब तुम खा रहे हो तुमको लगेगा ठंडा है ये,
अब वो अंदर से गर्म होगा.
और अंदर से जैसे ही तुम ब्रेक होगा और लिक्विड जाएगा, लिक्विड विल बी सुपर हॉट. ओके. दूसरा है कि माइक्रोवेव में यू शुड नॉट पुट मेटल्स, राइट? एंड यूजुअली मेटल्स जो खाना रखते हैं जिसमें कंटेनर्स, स्टील
You
कंटेनर्स.
put glass
like-
bowls in a microwave.
Pardon?
You put glass bowls in a microwave.
Yeah, glass bowls. And
Like
that's why, yes, aluminum foil is also prohibited, because aluminum is a metal finally.
No, so but like why don't I put a metal into a microwave?
Oh, never thought of it. What metals may get you electric shock. ऐसा पढ़ा है. क्यों होगा electric shock? Because
So like my mom told me, if you put the metal inside a microwave, the microwave is gonna blast.
kind of. I have never. I'll
Similar thing will happen if there's like a battery inside it, right?
battery is metal, that's why. But I'll read and tell you why it happens. Okay. It
Right.
has to do something with charge flow. I think I'll tell you. Okay.
Right, that's today's homework.
Okay. So now the next thing is that we are for theory, we are for this chapter, for this year's grade, we are assuming the device is a perfect heater. Okay. If it is a perfect heater, so what perfect heater kya karega? Whatever power is coming, it will convert to heat. Okay. Whatever power is coming, it is converting to heat. So all the power into time will give you energy, right? Energy or work, energy oblique work oblique heat, ये सारे सेम है. एनर्जी, वर्क, हीट आर सिमिलर होते हैं, सेम नहीं होते तो सिमिलर तो होते हैं. ठीक है. सो एवरी टाइम power into time will give you energy oblique work oblique heat. Okay. See, you should understand that in any device, power into time will be energy in any device, but not only in a perfect heater that energy will be equal to the heat. Okay. The total sum of energy, suppose you give 100 joule to a device, right? A bulb क्या करेगा? Most of it, 90 joule it will convert to light, but 10 joule it will convert as
Heat.
right?
Yeah.
फैन को 100 दिया तो वो 90 किस में कन्वर्ट करेगा?
Motion, kinetic.
काइनेटिक एनर्जी. और 10 किस में कन्वर्ट करेगा?
Heat.
एनर्जी में. यस. एक परफेक्ट हीटर क्या करेगा? 100 जूल दिया,
100% heat.
100% हीट. तो उसी के लिए ये फॉर्मूला होता है, सिर्फ उस डिवाइस के लिए जो तुम्हारे सिलेबस में वही डिवाइस है, परफेक्ट हीटर डिवाइस है. ठीक है. उसके लिए फॉर्मूला है पावर इनटू टाइम इज इक्वल टू हीट. वेरी सिंपल. Power into time is heat, energy is heat. Okay, all that energy is converted to heat.
So is there such a thing as a perfect heater in real life?
Real life.
Like you said, superconductors and stuff. So is there a perfect heater?
Yes, if you do you have perfect conductor?
So you talked about superconductors. You said they're hypothetical.
Yeah, so perfect heater will also be hypothetical.
Okay, right.
There will be some loss of heat. There will be some heat is infrared. I'll tell you about heat. Okay, what is heat? Okay, what is heat? देखो इधर क्या होता है. Heat कैसे बताऊं? Heat is electromagnetic waves. So no, heat is some part of it will go to electromagnetic wave. Okay, so you will have some. It is not possible. Okay.
So could you tell us what heat is?
थोड़ी देर में.
Okay.
Okay. अभी so you should understand that the when we write power into time is heat. So heat का formula क्या हुआ? Heat का formula power into time, और power कितना था? VIT. So heat is also VIT. It is also I square RT. It is also V square by R into time. ठीक है? ये हीट के सारे फॉर्मूले हैं, लिख लो. मतलब सिंपल है ना, मतलब पावर के फॉर्मूले याद है तो हीट के फॉर्मूले भी याद है, बस इनटू टाइम करना है. ठीक है ना? ओके, कूल एवरीवन. एक फॉर्मूला ये हो गए, ये एक सेट ऑफ फॉर्मूले हो गए जो तुमको याद रखने हैं. एक फॉर्मूले है ओम्स लॉ, तो ये हीट का फॉर्मूला है. एक ओम्स लॉ है विच इज V इज इक्वल टू आई आर. और एक है करंट का डेफिनेशन, करंट I इज इक्वल टू Q बाई टी. ठीक है? Just I'll take a quick roll call. Hriday, Garvit, Vansh, Ishan, and Sohani. Have I missed anyone? Hriday, Garvit, Shivansh, Ishan, and Sohani. Okay. Okay, so we'll be doing now problems from sample problem. Just write questions, okay, and question answers. So question is, a PD potential difference of, this is potential difference, okay, of 250 volt is applied across a resistance of 500 ohms is applied, okay, 500 ohm in iron sums, okay. Find current. Second, find heat energy. Find heat energy in 10 seconds. So the first thing, the V is given 250, V is given 250 volt, R is 500 ohm. So what is I? I is V by R. So it is 250 by 500. So it is
0.5 amperes.
0.5 ampere. And then the for heat energy, you first need power. So the power is VI
250 into 0.5.
250 into 0.5, which is 125. Okay, it is 125. And so unit क्या होता है power का, ईशान?
So power,
Yes, yes.
kilowatt per hour.
No, no, no,
No, kilowatt hour.
no.
No, that's commercial.
Just what?
Watt, yeah.
Okay, sorry. What? Power is 125 watt. Now they're asking heat energy. Heat is equal to power into time. So it is 125 watt into 10 seconds. So it is 1250 joules. Okay. So, Hani, have you understood this problem?
Yes, sir.
Hriday, have you understood this? Oh, Okay. Okay. Next question is, a current of 4 ampere is passed through a R resistor for 10 minutes. Okay, you have to always put time in seconds, okay? Everything should be in SI units. So resistor for 10 minutes, and question at 2.88 into 10 power 4 joules are joule of heat are produced. Joule of heat is produced. Okay.
So define.
बताता हूँ. Power and voltage. You have to find power and second voltage. Okay. All of you please do this and send it to me. Okay. Don't like speak it over the call.
Sir, can you say how much heat is produced? 2.88, right?
Into 10 to the power 4.
Okay, 2.88 into 10 to the power 4.
Okay. So Garvit,
Yes, sir.
have you sent this problem?
Sir, I know, sir. I'll just send it.
Okay. Have you found power?
So do we send it personally or in the group?
Personally, you found power, Garvit?
No, sir, I was doing it.
So V is equal to I into R, right?
V is equal to IR, yes. So here the given, what is given? The time is given,
So
which
now
is
I'm sorry.
10 into 60, which is 600 seconds. And you have given 2.88 into 10 power 4 joules of heat. So heat is given, which is 2.88 into 10 power 4 joules. Also, I is given, I is 4 ampere. So you can find power. Power is nothing but heat by time, right? Power is heat because heat is power into time. So which is equal to 2.88 into 10 power 4 divided by 600. Now what you do is you make it a 4 a power, you use 2 here, you get 288 into 10 power 2 divided by 6 into 10 power 2. Cancel 10 power 2, 10 power 2, you get 288 by 6, which is 6 4s are 24 and 6 8s are 48. So that is 48 watt. Okay. And then they're asking voltage. You
So
know,
is it okay if we found resistance first and then we did power?
pardon?
That's what I did.
Is it okay if we found resistance first and then we did power and voltage?
Yes, it is okay. That is okay. You can do I square RT, right? And then do a
Yeah, that's right.
the voltage is equal to power is V square by R or R is V square. Right formula है क्या भाई V का? V is IR, no?
V is IR.
Yes, sir.
I value is 4 into, लेकिन R तो नहीं पता ना?
So we have to find R. R will be 3 ohms.
Yeah, so when we put the I square
V, right?
VR, yeah, then you will find resistance is 3 volts.
Correct,
And then
correct, correct.
we do 4
volts.
into 3,
And
we
then,
get 12.
yeah, 12 volts.
Power is VI, so for 48 is equal to V. V और I, अरे यहाँ से डायरेक्ट आ जाता है ना? Power is VI. यहाँ से
No, so like we didn't find power first.
अच्छा
First we found
ठीक
resistance.
ठीक है ठीक है तो वोल्टेज आ गया 12 वोल्ट आ रहा है ना
Yeah.
ठीक है एवरीवन हैज गॉट दिस और डू यू वांट टू आस्क समथिंग बोलो everyone has understood this does anyone have question
सर इसमें हमने रेजिस्टेंस नहीं निकाला ना विदाउट रेजिस्टर
हाँ मैंने जैसे बिना रेजिस्टेंस के भी निकाला है without involving resistance you can find with involving resistance okay
ओके
ठीक है there is one more good question which involves charge so this question says it is there in the Aschanka example 2 okay sample problem 2 it says question says calculate heat produced when 96,000 coulombs of charge is transferred charge passes in 1 hour through PD of 50 volts okay, through PD of 50 volts तो क्या क्या दे रखा है यहाँ पे Q दे रखा है which is 96,000 कूलम टाइम दे रखा है टाइम आवर में नहीं लिखना है So how much is in seconds, Ishan?
So it will be 60 into 60.
Correct. 60 into 60 seconds. And the voltage is given, which is 50 volts. So क्या निकाल सकते हैं ईशान बताओ?
We can find out I, which is 96000 divided by 60 into 60.
Very good. 160 आता है 16 6 हाँ, and then again 160 by 6 will not be a good number, so I'll just keep it like 80 by 3. हाँ, see whenever ये important चीज है, whenever they are asking question में heat produced, they are not asking you current, right? So current is an intermediate thing which you are finding, so you don't need to find it with pura decimal, you can just keep it like this. Okay, find ampere and I is q by t, and what else? Then Ishan,
Then you can do R is equal to VI, right? We can use that.
R is equal to VI.
Yeah, because we can V is equal to IR. That way R is equal to VI, right? V by I. Sorry.
Yes.
So then we can do 50 by 80 by 3. Yeah.
Okay. Is the value same as what you're getting? What I'm getting?
So I'm doing it right now.
Okay.
That's the same thing.
So will we convert this to decimals?
No,
Okay.
I square RT. So I square is 80 by 3 into 80 by 3. R is 15 by 8 into time is 60 into 6. Right, and 320. So you have 8 zeros count करते हैं, ठीक है? Zeros कैसे? 1 0 2 0 3 0 4 0, right? Okay, zeros 1 2 3 4. Okay, and so it is 8 into 5 into 2 into 10 power 4, right? Okay, and this 5 into 2 again, it is 8 into 10 power 5 joule. Okay, मेरा आंसर गलत क्यों आ रहा है? 1 second.
No, so it should be 800 into 5 into 1200. That means
There is 60
4000
also.
into 1200.
I forgot the 60 part. There is 60 also. No?
Yeah, so you have to multiply it into 6.
4 0 और एक 6 भी है. 48 into 10 power 5, no?
Yeah.
48 into 10 power 5 joule, or you can write it is also equal to 48. Actually scientific notation में ये 4.8
4.8 into 10 to the power 6.
और जूल है, तो इसको लिख सकते हैं. ये इंपॉर्टेंट है, देखो 48 it is written 4.8 into 10 power 6 joule, or it is 4.8 into 10 power 3 kilojoule. Okay, अब मैं देखो तुमको दिखाता हूँ कि what could be wrong if you took decimals. ठीक है, मैं तुमको दिखाता हूँ. देखो exactly what I was trying to say. तुम्हारा आंसर कितना है? 4 आंसर है हमारा 4.8 into 10 power 3 किलो जूल. ओके, ठीक है, 4.8 into 10 power 3 किलो जूल. अब देखो ध्यान से इधर जो उन्होंने सॉल्व किया है आरएस में, मतलब सॉरी एसचान में, देखो उनका आंसर ना थोड़ा क्लोज है बट उतना नहीं है. उनका आ रहा है, हमारा आ रहा है 4.8 into 10 power 3 which is 4800, right?
Yeah.
Yes, sir.
उनका देखो क्या आ रहा है, 4800 थोड़ा कम आ रहा है ना.
It's 47,
ठीक
80.
है, ये गलत आंसर है. अरे क्यों गलत है? क्यों गलत है? उन्होंने
Why
क्या,
though?
उन्होंने आई को देखो यहाँ पे अप्रोक्सीमेट किया ना, डेसिमल किया, आई को डेसिमल किया,
सेम थिंग बता
आर को भी डेसिमल किया। जब ये दोनों डेसिमल मल्टीप्लाई किया तो ऑफकोर्स तुम्हारा आंसर दूर चला गया ना एक्चुअल वैल्यू से। आया समझ में? तो अगर एग्जाम में क्वेश्चन आया और आंसर था 4800 किलो जूल, पहले एग्जामिनर देखेगा ये तो गलत है, 3 में से 1 मार्क तो काट ही लेगा यहाँ पे ना। अंडरस्टूड? मिल भी सकता है 3 मार्क्स, ऐसा नहीं बोल रहा हूँ कि नहीं मिलेगा, बट देयर इज अ पॉसिबिलिटी ऑफ योर मार्क्स बीइंग कट। ओके, सो देयरफॉर अगर एक्सप्लिसिटली नहीं पूछा है कि व्हाट इज द करंट और व्हाट इज द रेजिस्टेंस, डोंट फाइंड द डेसिमल वैल्यूज। इवन इफ यू आर लाइक, तुमको मजा आता है डेसिमल निकालने में, निकाल लो, पर उसको यूज मत करो आगे कैलकुलेशन में, फ्रैक्शन ही यूज करो। ओके, the problem occurs when you try to use the decimal value in the formula. Okay, shall I move forward? Okay, then you do this question like, ये जिस पेज पे, एक मिनट, सिंगल पेज कंटिन्यूस, just do 17 and 18, question number 17 and 18.
So which page is this?
ये यार सामने दिख रहा है ना, कर ले, पता नहीं, the PDF is different.
So question 16 and 17.
17 and 18.
Right. So in the 17th question, they're asking at what rate will heat be produced in it? So like at what rate?
The rate of heat production is also called power. The rate of heat production is also called power.
Oh, okay. So then, fine. So wait, can you explain how?
Rate at which heat is produced. See, the heat was power
By
into
D by
time. Hello?
yes, sir.
Heat is power into time, right?
Yeah.
So power is heat by in a time.
Okay, got it.
So done 70/80.
Guys, please do send me quickly.
Shall I send you the questions on your like personal?
Well, I've sent the questions on your WhatsApp numbers.
Yeah, I have received from Suhani, Garvit, Hriday, Dhruvi, Ishan. Okay, and Shivansh, everyone I have received. Uh, don't turn off your videos. You were asking me, Garvit, something.
No, I was telling I sent it and I was not asking.
So the first 17th answer is 1250 joules, 1250 joules. Right, everyone? Are you getting this?
Yes, so send.
Yes, sir.
Okay. And 18th answer is 1800 joules.
Yes, sir.
Right, yes, sir.
00. Okay.
So should we write these in scientific notation or?
No, it's fine. Smaller numbers, 4-digit numbers, still you can write like that. Okay. And then if the number is 5-digit and onwards, bigger, then you should write it in. Should. Okay, should. There is a big should. Okay, 20. What is the, okay, so Suhani, tell me the answer of 22. The screen for 22.
Oh, yes, sir. Well, yes. Well, 1 second.
So which question?
The screen visible 22. Yeah. Suhani,
Yes, sir.
what do you think about this problem?
Should it be the A?
वो पूछ रहा है heat produced by passing an electric current through a fixed resistor is proportional to square of heat का formula क्या है?
The P into T and T like I square R into T.
ठीक है, वो पूछ रहा है square किस पे लगा है?
The I पे
I क्या है?
current, magnitude of current.
Correct. Suhani 23.
Yes, sir. The current passing through an electric kettle has been built. The heat produced will become. So it will become 4 times.
Correct. Okay. Write the next theory about fuse wire. Write about fuse wires. So fuse wires are very thin. Because they're very thin, and you have a formula R is equal to rho L by A. Resistance of a device, resistance of a resistor is a rho into L by A. If they're very thin, their A is small. Okay, A is small. If A is small, this implies R is big. They have high R, their large value of resistance. So a fuse wire is a very thin wire. Okay, it's a very thin wire. Also, it is made of metal which can melt easily. Okay, which can melt easily. It has a low melting point also. So it is thin. So there are two properties. This is a very thin first property, and second property क्या है? Low melting point metal. Low melting point metal. Okay. Two properties. They are very thin and they are made of low melting point metal. Because they are very thin, their cross section area is small. So from the formula R equal to rho L by A, their R is big. Now, if the R is big, what happens? H is equal to I square RT. So the heat which is produced is more, okay, because H is more. R is big, so H is also big. It is large, okay. Large heat is produced. So if large heat is produced, okay, and the melting point is low, it will melt easily, okay. So the fuse wire is made such that if it is connected before the device in the wire, before the device. So if a current larger than the permissible value passes, it just melts the fuse wire. It does not have a chance to go through the device. Understood? All of you have understood the working of a fuse wire?
So, but then why does R need to be more? If anyways the wire melts, why does R need to be more?
So that heat produced is more.
So, but then if heat produced is more,
Hmm.
fuse wire melts. Why would you want the fuse wire to melt unless there's an emergency?
So the fuse wire will be such that it should allow 5 ampere. Let's say the fuse is made of 5 ampere, like till should permit 5 ampere. Okay. So it will not melt when the current is 5 ampere, but it will melt if the current is 10 ampere. So there is a very slight window margin of operations.
Sir, I have one question.
Or no, one second. Is this doubt answered? I don't think so.
No, sir, not at all.
What
I'm not getting any.
can you repeat your doubt?
No, like, so why does R need to be big if the wire is melting anyway?
No, इतना भी कम नहीं है ना.
So I mean, like, no, if the wire is melting anyway, if there's too much
Anyway,
current,
anyway, it has a low. It's still a metal.
yeah,
Still a metal. So metal
you
have
conduct,
it conducts.
right?
And metals, as a general, if you see, metals have a melting point of around 1000 degrees Celsius. If you could just Google it, just Google and tell me what is the melting point of iron. I think it's 800 degrees Celsius. In degree Celsius में सारा निकालना.
So 1538 degrees Celsius for iron,
Oh, 15
1538.
पक्का.
According to Google, yes.
Okay. So see, मतलब copper का देखो.
Good. 1085.
1085.
Yeah. 1 degree Celsius.
अब देखो टिन का देखो टिन
231.9 degrees Celsius.
किसका
10.
फिर से बोलना
231.9 degrees Celsius.
231 231 बस ना
Yeah, that's it.
हिट का है ना 2000 नहीं है 231
No, it's just 231. That's all.
लेड का कितना है लेड का
327.5.
फ्यूज वायर इज मेड अप ऑफ टिन एंड लेड का alloy. Okay, so it is very less. Usually जो metal copper मतलब दो wires are made up of copper, which is you said I think 1000, right?
Yeah, 1085.
हाँ तो कम है पर मतलब तब भी 231 you can't achieve 231, right? I mean 231 is the maximum temperature of your cooking vessels. वो जो 231
No, 231 is 10.
नहीं maximum temperature which is achieved in your while in the kitchen tawa.
Oh, okay. Yeah,
You heat the tawa.
yeah.
I think that the tawa goes up to 200 degrees Celsius. Okay.
So I can put my hand in there and check.
No, don't put your hand in check. Don't put your hand in anything above 70 degrees Celsius.
Right, will do. So.
Will not do.
Will not do. Fine.
So still the R is, I mean, you understood, no? The R is big and you need sufficient amount of heat for it to melt. Okay.
Right. So, but then why does it need resistance if it's melting anyway?
See, the current is same.
Yeah.
Some current is flowing through a wire, okay? By putting a fuse, you're not going to change the current because fuse is a very small device.
Yeah.
Okay. So now what can you change more in this? Which value can you change in this equation? H. Only the resistance.
Yeah.
Understood. Suppose there is a device which takes 5 ampere of current.
Hmm.
Fuse is used to protect such devices lest a current more than 5 ampere comes, like 10 ampere comes.
Yeah.
And the fuse is designed or instructed to melt. So fuse is placed just before the device. It's a very small device. Okay. It is like smaller than a pen cap. Okay. Usually. And its resistance is big. So it produces more heat and therefore it can melt easily.
Right. So my next question is this.
Hmm.
If you said the fuse wire is as small as like this little cute.
Yeah, the
pencil.
length is very small.
Yeah. So isn't length directly proportional to resistance?
Correct.
Wouldn't it be better if
Hmm.
instead of decreasing the area, they just made the length longer?
Length longer.
Yeah.
Good question. Good question. If you have a longer length, you should also understand the mechanics of this. You need a wire which melts, right?
Yeah.
If you have a longer wire, the heat will produce everywhere. It will produce everywhere, right?
Correct. So it takes more time to melt.
Yes.
Right. Okay.
Okay.
So basically you're picking metals
Hmm.
with a higher or a lower resistivity. Resistivity.
A higher resistivity, but a lower melting point.
Okay.
Okay. Right. Okay. And heating devices are usually made up of high resistivity heating devices. So coil of a filament. So I think this answer 25 ka 25 का I think it's nichrome. It's nichrome. लिख लो ये क्वेश्चन लिख लो.
So 1 minute. I'll write that resistivity.
Okay. ट्वेंटी सेवेंथ का आंसर बता दो.
So thick and short. Option B. Because if it's thick, area is going to be more, resistance will be less. Heat produced will also be less. So it will take more time for the wire to melt.
Correct. Okay. Now there is one thing. एक ये बात करनी थी. ये वाला लिखो लिखो ये पूरा ना. इस पूरा क्वेश्चन को लिख लो. 34 का पूरा क्वेश्चन कॉपी कर लो ऐसे. पूरा टेक्स्ट लिख लेना. ठीक है. देखो. Now write this. ये लिख लिया सबने?
So 1 minute.
जल्दी करो जल्दी।
Sit down.
So see, suppose you have a circuit at home. The plug है, plug point, and there is a switch. Okay, usually your usual switchboard. Let's say you are using a device which involves heating. Can you name a device?
A heater, because why not?
Heater or a press iron. Okay, so it's you are using it for heating, and basically क्या होता है, वो एक coil होता है बस ऐसे, ठीक है? That's it. It's a coil. It's a high resistivity metal coil. High resistivity metal भी नहीं होता एक्चुअली, वो alloy होता है, high resistivity alloy coil. Okay, it has some resistance R. Okay, now what happens, what is fixed in a household power supply? The V is fixed, right? V is fixed, and how much is it?
In India, 220 volts.
The 220 volts. Now suppose, so if you want more heat implies you want more power, and we know the formula power is, we'll use, because the V is fixed, we'll use the formula power is V square by R, right? Yes or no? Understood? हम्म, समझ में आ रहा है कि नहीं आ रहा है? पक्का ना?
Right.
ठीक, तो R कितना हो जाता है? V स्क्वायर बाई पी। R इज V स्क्वायर बाई पी। समझ में आ रहा है ये भी?
Yes, sir.
ठीक, अब ये बताओ, इफ यू वांट मोर हीट implies मोर पावर, ये भी पता है, इसको लिख लिया, implies पावर अगर ज्यादा है तो रेजिस्टेंस क्या है?
Resistance
Has to
will
be
be
more. No,
R is less,
less.
एंड इसी का उल्टा अपने आप बोलो, क्या लिखेंगे? बोलो, लेस
Less heat, less
Yeah.
power, more
more
R.
resistance.
R इज मोर। ठीक है, कितना लिखा, लिख लिया? ठीक है, अब इसको हाउ डू वी कंट्रोल दिस, कि कैसे ना, तो अगर पावर ज्यादा करनी है तो रेजिस्टेंस कम करना है, और पावर कम करनी है तो रेजिस्टेंस वी हैव टू इंक्रीज, राइट? देखो अब करते कैसे हैं, ये वेरी इंपॉर्टेंट है। आपके पास दो टर्मिनल है, ये दो टर्मिनल है, ये दो टर्मिनल जो है ना, ये मैं यहां बना दे रहा हूं, ठीक है? ठीक, फिर आप क्या करते हो, फिर आप एक वायर बनाते हो, एक मतलब एक कॉपर वायर है, ये मान लो कॉपर वायर है, ठीक है? ये जो रेड कलर का ये कॉपर वायर है, ठीक? और जो, ध्यान से देखना, ये जो ब्लैक कलर का है ना, ये तुम्हारा हाई रेजिस्टेंस वाला क्या है? हाई रेजिस्टेंस वाला अलॉय है, हाई रेजिस्टेंस वाला अलॉय, ठीक है? समझ में आया? ठीक है, अब देखना, एक मिनट रुकना, 1 सेकेंड। देखो, ये ध्यान से देखना, ठीक है, ये बहुत इंपॉर्टेंट है। हाउ डू थिंग्स वर्क। ये जो राइट साइड वाला वायर है ना, राइट साइड वाला जो वायर है, जो कॉपर वायर है, उससे ना एक वो लगा, एक लगा हुआ है, एक स्लाइडिंग मूव स्लाइडर, एक स्लाइडर है। द थिंग अबाउट दिस स्लाइडर इज कि ये, कि अभी ऐसा है ना, इसको तुम उठा के यहां भी कर सकते हो, इसको उठा के यहां भी लगा सकते हो, यहां भी लगा सकते हो, यहां भी लगा सकते हो। ओके, अंडरस्टूड। इसको उठा के अगर तुमने यहां पे लगा दिया, मान लो यहां पे, ठीक है, यहां पे डायरेक्टली इस पॉइंट पे कनेक्ट कर दिया, ब्लू पॉइंट पे कनेक्ट कर दिया, या फिर दूसरे केस में हम देखेंगे ऑरेंज पॉइंट पे कनेक्ट करने से क्या होता है। ध्यान से देखना, ठीक है। इफ यू कनेक्ट इट टू द ब्लू पॉइंट, द करंट विल कम फ्रॉम दिस, यहां से आएगा और यहीं से निकल जाएगा। अंडरस्टूड, अंडरस्टूड। इफ यू कनेक्ट टू द ऑरेंज पॉइंट, करंट ऐसे आएगा, ऐसे आएगा, ऐसे आएगा, ऐसे आएगा, फिर ऐसे निकल गया, ठीक है, ठीक। सेकेंड थिंग इज दैट ये जो वायर है ना, कॉपर वायर, इनका रेजिस्टेंस तो वर्चुअली नेग्लिजिबल है, जीरो रेजिस्टेंस है इनका, मतलब इन फ्रंट ऑफ दिस, इन फ्रंट ऑफ this alloy, the copper wire is zero resistance. Okay, so effectively in this path, when it was blue, the resistance was this much. Understood? Hello? And when you're connecting to the orange point, the resistance is this much. And because the resistance is rho L by A, it is, resistance is proportional to length, in which case resistance is more. In which case resistance is more?
Orange.
So the
When you connect
orange.
longer path, right?
Yeah,
When
longer.
you connect to the orange path. So what happens, तो हम जब whenever अगर एक इलेक्ट्रिकल हीटिंग एलिमेंट है, ठीक है, और उसमें मुझे इसका, ये तुमको समझ में आ रहा है कि जो मैं भी यहाँ पे कनेक्ट कर देता हूँ, लेकिन तुमको समझ में भी आना चाहिए कि ये वाला जो केस है ना, ऑरेंज वाला, ये वाला आर्मोर है।
So less power and less heat.
हाँ, मैं इसको एक्चुअली फिर ऑरेंज से ही कर देता हूँ। ये वाला केस जो है, ये आर्मोर वाला केस है, और जो ब्लू वाला केस है वो आरलेस वाला केस है। करेक्ट? So while when you are adjusting the power of a heater and you want more power, you are switching। मुझे एक फैन में भी वही होता है, एक नॉब होता है ना फैन में।
Yeah, like if you rotate it.
हाँ, yes, that knob does nothing but it changes the length of the resistor through which the current passes. Okay,
So like, does it cut part of the resistor, or like does it like retract part of the resistor, or how
fine,
does
yes,
it?
yeah, मतलब बेसिकली तुम ये चेंज कर रहे हो ना, ये स्लाइडर कहाँ कनेक्ट हो रहा है, बस।
Yeah, blue point or red point, which means
करेक्ट। ओके,
right.
so this is important to understand that if the bulb is glowing brighter, or the heater is getting more heat, your are more heat, right? Then a lesser part, the current is passing through a lesser path, shorter path. Understood?
So that's what rheostat does, right? Like you adjust the slider on the rheostat.
Yes, exactly, it is a rheostat. Every adjustable power device is a rheostat. Okay,
Right. Yeah.
this is a rheostat, ये rheostat ही है। Okay,
Hmm.
understood? One more thing, ये फिनोमेना समझ में आ गया सब? किसी को डाउट है इसमें?
So should we write?
Write it. Today I have to cut off exactly at 8, therefore write fast. Hmm. Guys, have you written it?
Almost there last night.
हृदय, रेजिस्टेंस कम है तो पावर क्या होता है? क्या होता है? लिख दे, चैट में लिख दे। इंक्रीजेस, हाँ ज्यादा होता है, और रेजिस्टेंस ज्यादा है तो पावर लेस। यस, ठीक। हाँ, अब एक दूसरा फिनोमेना है, वो ये लिखना है कि मान लो ना तुमने एक रेजिस्टर वायर लगाया, ठीक है? जब उसको लगाया है, स्टार्ट किया है, तब वो किस टेम्परेचर पे है? मतलब अभी ऑन नहीं किया है, किस टेम्परेचर पे है वो? जीरो नहीं है बेटा, जीरो नहीं है, रूम टेम्परेचर पे है ना। जब ऑन नहीं किया तो रूम टेम्परेचर पे है। रूम टेम्परेचर अप्रोक्सीमेटली कितना होता है? अप्रोक्सीमेटली
25।
हाँ 25, ठीक है। तो तुमने अभी उस तो अच्छा, अभी ये भी तुमने पढ़ा, हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट भी पढ़ा। इसका मतलब क्या होगा? अगर उसको ऑन कर दिया तो उससे करंट पास होगा, राइट? राइट, स्विच इट ऑन, इट पास, इससे करंट पास होगा, उससे करंट पास होगा तो उसमें हीट प्रोड्यूस होगी। हीट प्रोड्यूस होगी तो उसमें टेम्परेचर बढ़ेगा। टेम्परेचर बढ़ता है तो क्या होता है? इंक्रीज होता है। वी स्टडीड, नो, रेजिस्टेंस इज प्रोपोर्शनल टू टेम्परेचर। इफ टेम्परेचर इंक्रीज, रेजिस्टेंस इंक्रीज। लिखो, लिखो, अब शुरू से लिखो। बिफोर स्विचिंग ऑन द रजिस्टर, its temperature is at room temperature, right? समझ में आ रहा है ना सबको? after after some time of switching, like after some time it is switched on, due to the passing of heat, its temperature increases and therefore its resistance increases. ठीक है? हेलो, ओ हेलो, क्या बात है, समझ में नहीं आ रहा क्या?
Got it.
Its resistance increases and therefore the power decreases. Understood?
Yes, sir.
तो जो बल्ब है वो शुरू में कैसे ब्राइट ग्लो करता है कि डिम ग्लो करता है? शुरू में जब स्टार्ट करोगे, ऑन किया जस्ट अभी, तब कैसा ग्लो करेगा? ब्राइटर या डिमर देन?
Dimmer.
नहीं, शुरू में ब्राइटर करेगा ना।
No, but then if resistance increase, there would be more heat, which gives you more light, right?
अरे अभी
Because
डिस्कस किया कि रेजिस्टेंस इंक्रीज। देख यहाँ पे, सुनो, अच्छा डाउट है तुम्हारा, बट प्रॉब्लम ये है, तुमने बोला रेजिस्टेंस इंक्रीजेस सो देयर विल बी करंट इंक्रीजेस, ये बोला।
no, the light would increase, right? The
वाई, वाई,
moment it
वाई,
glows.
वाई?
Oh no, it's based on light. Oh, okay.
बिकॉज यहाँ पे V कांस्टेंट होता है, I कांस्टेंट नहीं होता. Okay, so therefore if with time temperature increases and therefore resistance increases, and because resistance increases the power decreases. Okay, so a bulb which glows brighter initially will with time will be dimmer. Understood? बट एक पॉइंट के बाद ना उसका टेम्परेचर फिक्स हो जाता है, मतलब उससे ज्यादा नहीं बढ़ता, तो उस पॉइंट के बाद वो डिम भी नहीं होता. अंडरस्टूड? हेलो?
So wait, but temperature is directly proportional to power.
ऐसा बोलना नहीं चाहिए, मतलब मैंने पहले ऐसे डायरेक्टली मत बोलो. टेम्परेचर नहीं, टेम्परेचर इज प्रोपोर्शनल टू रेजिस्टेंस.
No, power.
नो.
H is equal to P into T.
क्या बोला?
H is equal to P into T. So
दैट टाइम,
H.
that is time.
No, so then heat is proportional to power, right?
No, heat is proportional to power, heat is not proportional to temperature. ये H
Oh,
इक्वल टू T में वो
yeah.
टर्म है, T स्मॉल t लिखा है इसीलिए.
So what I meant was heat.
Small t is time, capital T is temperature. Okay.
Yeah, right. So what I meant was heat. Like I was saying something else. So if power is more, the brightness of the bulb is more. That we discussed last class, right?
Correct.
But if heat is more, the power is more, and so the brightness would be more.
Correct.
So aren't you saying that like as it gets hotter, the bulb gets dimmer, something?
Yeah. Oh, as the bulb gets hotter, because say there is some heat produced, right?
Yeah.
I square RT. You switch on the bulb, you pass current through it.
Yeah.
Because of this current, there is heat in the bulb.
Yeah.
Because of this heat, the molecules of the bulb filament start moving more rapidly,
Yeah.
which is same as saying temperature is more.
Yeah.
Because of this temperature, the resistance of this filament increases.
Yeah.
Because of this increased resistance, right, the power of this as a whole device becomes lesser.
Yeah.
So the bulb gets fainter after a few minutes of operation.
So the statement which I said is more or less incorrect.
More or less.
Incorrect. Like
What was this?
just because heat is proportional to power does not mean heat is proportional to brightness, right?
Which heat? See, you have to be clear about this. Heat which is dissipated,
Outputted.
yes,
Yeah.
is the power.
Yeah.
So you took you gave the device some input power, and today's class we are doing the assumption that all of the resistance, all of the power is being converted to heat,
Which is not the case.
which is, sorry,
Which is not the case in actual life.
why? Oh, I mean वो तो नहीं होता, हाँ, मतलब.
That's why the more the heat is, the more the particles vibrate, the more resistance you get, and
Yes.
so the less the power is.
Yeah, you are confused between two powers. I'll tell you next class. Okay, I have to leave at right now.
Fine.
Confused between two powers. Okay,
Yes, sir.
fine. You do all the questions of S. Chan. Okay, you do all the which questions you have to do the blue short answer type questions and the HOTS. Okay.
Right. Yes.
Color wise, one short answer type questions are graded in light blue, and HOTS is
So can you mention it in group?
yeah. ठीक है.